In this video, ATtiny85 is interfaced with MAX7219.metrics module using SPI connection. The MAX7219 is programmed using C language without using any library. The ATtiny85 has a circuit called Universal Serial Interface that provides 2-wire I2C and 3-wire SPI synchronous communication. To interface SPI peripherals with the ATtiny85, we need to program the internal registers of the Universal Serial Interface circuit so that pins PB0, PB1 and PB2 becomes the SPI lines of the tiny microcontroller. In this video, the Universal Serial Interface is not programmed, but rather the digital pins PB0, PB1 and PB2 are used as normal digital I/O pins to give us the required SPI lines to interface with the MAX7219 module. In future videos, the Universal Serial Interface registers such as the control register, the status register and the data register will be programmed to either give us SPI communication or I2C communication. MAX7219 is interfaced with a microcontroller through 3 SPI lines: data in, clock and chip select. Chip select is used to enable or disable the MAX7219. A low logic here will enable the device, and the clock signal is used for synchronizing the input data into the MAX7219. MAX7219 is programmed by sending 2 bytes of data. First we send the command byte and then we send the data byte. The command byte defines the meaning of the data byte, and the data byte will be the data to be displayed on the module, or it will be a control byte used to initialize the device. Command bytes from hex value 01 to 08 will enable digits 0 to digit 7 or row 0 to row 7 on the MAX7219.metrics module. For example, if we send this command byte, then we enable digit 1 or row 1 of the module, and then we send this data where this byte will be displayed on that row. This is the most significant bit and this is the least significant bit. Command bytes 09 to 0F are used to initialize the MAX7219 module. Detailed explanation of these commands can be found in the data sheet. As an example, this piece of code written in C language will initialize the MAX7219 module. So here we are disabling the decoding mode, and here we are setting the light intensity to 3 and the scan limit all digits on, and we are turning on the module. A circuit diagram of the implemented system is shown here. We have the MAX7219 module interfaced with the ATtiny85 using SPI connection. The clock line is connected to pin PB2, the chip select is connected to PB1, and the data in is connected to PB0. We also have 2 push buttons connected to pins PB3 and PB4. Pressing this push button will display digits from 0 to 9 on the module, while pressing this button will display Tiny85. The sketch is made of 3 parts. We have the INO file, which contains the C code, and we have the S file, which contains assembly code, and we have a header file which contains the data bytes that will be sent to the MAX7219. Inside the setup function, we clear pins PB3 and PB4 so that they become input pins. And note here we are not using pin mode functions of the Arduino, but we are rather programming directly the register DDRB. Next, we call this function to initialize the MAX7219. Inside function MAX7219 initialization, we set pins PB0, PB1, and PB2 as output pins. Again, we are not using the pin mode function, but communicating directly with the register DDRB. Next, we call this function to send the command byte and the data byte to the MAX7219 display. And here we are executing this piece of code to initialize the MAX7219. So this would disable the decoding mode. This would set the intensity light level to 3. This would turn on all of the digits, and this would turn on the device itself. We call this function MAX7219 write and send the command byte and the data byte. The command byte is stored in this variable and the data byte is stored in this variable. Then we pull the chip select line low to enable the MAX7219. Again, here we are programming directly register port B and using this statement instead of the digital write function of the Arduino IDE. Next, we call this function and send the command byte, and then call the function again to send the data byte. And then we pull the chip select line high to disable the MAX7219. Again, we are replacing this statement with the digital write statement. We call this function and send this byte, which is then stored in this variable here. Inside the function, we are using this loop to loop 8 times so that we shift out most significant bit first, the byte, to the MAX7219. So first we need to put the clock low, and then we check the value of the most significant bit by masking the data or the byte with this value here. So if the most significant bit is 1, then we output a logic 1. Otherwise we output logic 0. And then we put the clock to high, and then we shift the byte to the left by 1 position and repeat the process until we have shifted out all of the 8 bits. After we initialize a MAX7219, and within the loop function, we first call this function to clear the display. Inside function MAX7219 clear display, and using this for loop, we will send zeros to all of the rows of the MAX7219. Back inside the loop function, and after we clear the display, we check the status of the 2 push buttons connected to pins PB3 and PB4 of the microcontroller. Note here we are using this low-level expression instead of the digital read function. If we press the push button connected to pin PB3, then this if statement becomes true and the program jumps to this function display from 0 to 9. Inside function display 0 to 9, we display the numeral 0, 1, all the way to numeral 9. The code of this delay function is written in assembly, which can be found within the S file. Back inside the loop function, if we press the second push button, then this if statement becomes true and we jump to this function. Inside function display ATtiny85, we display on the module ATtiny85. Finally, the data bytes used to sketch shapes on the module are stored in these one-dimensional arrays for the numerals from 0 to 9 and for the letters related to sketching Tiny85. In future videos, more projects will be implemented using the ATtiny85 microcontroller. Thank you for watching.